Let us solve the differential equation 2 dy dx minus y over x equals 5x cubed y cubed if y equals 1 when x equals 1. So first, let's try to check if we can change it into the form of a Bernoulli dE. Remember, our Bernoulli dE is dy dx plus p of x y equals q of x y raised to the power of n. That is if y is our dependent variable and x is our independent variable. But we can also have dx dy plus p of y x equals q of y times x raised to the power of n. So obviously in this dE, we're going to use this first one because we have dy dx already here. But since we have a coefficient 2 here, so we can divide both sides of the equation by 2. So dy dx minus 1 over 2x y equals 5x cubed over 2 y cubed. So we just wrote it into this form. So once you are already done reducing the equation into the Bernoulli form, all you need to do is to identify what your p of x is, what your q of x is, and what your n is. So in our case, our p of x is this negative 1 over 2x. That's negative 1 over 2x. Our q of x is 5x cubed over 2. And our n here is the exponent 3. So again, p of x is negative 1 over 2x. Q of x is 5x cubed over 2. And n is equal to 3. So we are going now to directly look for the integrating factor. So our integrating factor v is equal to e to the integral of 1 minus n p of x dx. So that's e to the integral of negative 2 because that's 1 minus 3. And our p of x is negative 1 over 2x dx. So we cancel negative 2. That's e to the integral of 1 over x dx. Or that is e to the power of ln of x. Therefore, our integrating factor v is x. Then we solve for our general solution. So for the general solution, our formula is Vy raised to the power of 1 minus n equals 1 minus n integral of V q of x dx plus c. So we simply substitute our V is x, so that's x, y, and our 1 minus n is negative 2. That's negative 2 integral of x, and our q of x is 5x cubed over 2 dx plus c. On the left side, that would be x over y squared. We cancel 2 there, so we have negative 5 integral of x to the power of 4 dx plus c. That would be negative 5 times x to the power of 5 over 5 plus c. Or that's x over y squared equals negative x to the power of 5 plus c. We can transfer x to the power of 5 on the left side. Multiply both sides by y squared as well. So that's x equals negative x to the power of 5 y squared plus cy squared. Or that would be y squared times c minus x to the power of 5. You can write it like that. So that is our general solution. But this problem is looking for the particular solution. So at y equals 1, when x equals 1, so we simply have to substitute to our formula, to our dE. So 1 equals 1 squared times c minus 1. 1 is equal to c minus 1, so c therefore is equal to 2. So substituting to get the particular solution. So x is equal to y squared times 2 minus x to the power of 5. That is our particular solution of a given Bernoulli PE.